Given the graph of f above, let g of x be the integral from 0 to x of f of t. So note that the area A is 5, area B is 8, and C is, oh, I don't have C. But it's asking me for the value of g of 7. So the value of g of 7 is going to be me saying g of 7 is now the integral from 0 to 7 of this f of t dt. Now, what you're being asked to do is find the area under the curve from 0, which is u, to 7, which is u. Any area above the x-axis is a positive area. So any area under the x-axis is a negative area. So you are actually not going to be 5, you are negative 5. So the area under the curve isn't me doing 5 plus 8. It's actually me doing negative 5 plus 8. Because whatever area is down here is going to cancel out the same amount of area up here. And so at the end of the day, my answer is going to be 3 here. Kind of tricky. The graph of the function f shown above has zeros at 0, 4, and 6. And has horizontal tangents at 2, I can see that there, and 5, I can see that there. Let g be the function defined by its integral. Oh, so I don't even see g. So g is the integral from 0 to x of f of t for what values of x is the graph increasing and concave down. So this is the graph of f, right? This is the graph of f. So what I'm thinking is fundamental theorem of calculus thoughts. What I care about is I care about g prime of x, and that will get me the increase-decrease part. Okay, so if it's asking me for increasing, I would normally take the derivative and find out where the derivative is positive or negative. Now, I want increasing, so I care about where g prime of x is positive. Well, what's g prime of x in this case? G prime of x is going to be the derivative of the interval. So it's going to be just the interval's gone now, and I'm left with f of x. That's what the fundamental theorem of calculus says. So I care about where f of x is positive. So if this is the graph of f of x, I care about where f of x is above the x-axis. And f of x is above the x-axis between 4 and 6. Now, in order for me to find concavity is going to be CU, CD. Concavity is going to be the second derivative. And I want it to be concave down, so I care about where the second derivative is down. Now, the second derivative would be me like going up here and saying, all right, so g double prime of x is going to be f regular prime, and I care about when that's less than 0. The derivative of a function means slope, so I care when the slope is negative, or when f of x is decreasing. This is f. F of x is decreasing from 0 to 2 and decreasing from 5 to 6. So that guy is going to be from 0 to 2, union, 5 to 6. Where do both of these happen at the same time? Well, if one of them happens from 4 to 6, then 0 to 2 has nothing to do with what I'm doing up here. This is from 5 to 6. So 5 to 6 compared to 4 to 6 means that all the magic happens between 5 and 6. Because that's where it kind of intermingles, if you will. If you will. And that's how you do it. Fun stuff. What is the integral from 1 to 3 of f of x? Well, we know that the integral from a to b of f of x is going to be the antiderivative from b at b minus the antiderivative at a. I'm given this information right here. So if I want from 1 to 3 of f of x, it's going to be f of, u would be my a, u would be my b, f of 3, capital F, minus capital F of 1. So let's see if I have that information. 1 goes to 3, and 3 goes to 8. So this becomes 8 f of 3 is 8 minus f of 1 is 3. And 8 minus 3 is 5. Baby. Fun stuff.